Alright guys, today we're going to be talking about factoring the polynomial function. So you can see I have this pretty big function right here, and it's asking me to factor this. Well, this is going to be really difficult to try to factor, okay, using the AC method, which I often talk about in my other videos. Okay, so we can't do that here. This isn't a quadratic. This is to a degree of 4. So we have to go about a different way of factoring this. Now, in order to do this problem, you're going to have knowledge on the rational root theorem. Okay, so if you don't know what that is, make sure you check out my other video that talks about that. Okay, so in order to factor this, we're going to have to set up the rational root theorem, and we're going to have to use synthetic division here in order to take this guy down a few degrees. Right now it has a degree of 4. Okay, we want to take this down to a degree of 2, and then we will try to go ahead and factor the rest of it. So in order to do that, we need to find the zeros. Okay, and we can use the rational root theorem, okay, in order to try to find that. So again, if you check out my other video, I talked about this, but the rational root theorem is just simply P all over Q, where P is my constant term. So in this case, it's going to be negative 240. Okay, and Q is going to be my leading coefficient. All right, in this case, it's going to be 1. And what we want to do is go ahead and write out all the factors for both of those. So if I do this, I'm going to have, and I'm not going to write out all the factors for negative 240. All right, I'm just going to write out the first couple, and then we'll see where that takes us. If I have to write more, I'll write more. All right, we know that we're going to have plus or minus 1. But we'll also have plus or minus 2. We will also have plus or minus 4. All right, and I'm going to stop right there. Again, we can keep going, and if we need to, all right, we can always add more here. And then I'm going to write the factors of my leading coefficient, or my Q value, which is just 1, so just plus or minus 1. And we're simply just going to do out these operations. So we know that 1 divided by 1, so plus or minus 1, that's a possible rational root. Okay, let's do the other one, plus or minus 2, that's another possible rational root. And plus or minus 4. Okay, now it's important to remember that these are rational roots, all right? So it's not going to tell us if there are irrational roots here. These are only for rational roots. And remember, the roots are where it crosses the x-axis. Okay? So here we go. We're going to go ahead and set up synthetic division now. Remember, we're trying to take this down 2 degrees. So right now it's a degree of 4. I want to take it down to a degree of 2, and then I'm going to try to factor it from there. Okay? So let's go ahead and set up our synthetic division. And remember, if it skips a term, you need to write a 0 in for that coefficient. Well, in this case, we are not skipping a term. We're going right from x to the 4th, x to the 3rd, x to the 2nd, x, and then our constant. We do not skip a term. Again, you are going to have to check out my other videos on synthetic division and the rational root theorem in order for this to make sense. So I'm going to go ahead and set this up. Let's set up our synthetic division. So we're just writing the coefficients here. So in this case, it's going to be 1, negative 8, negative 1, 128, okay, and then negative 240. Negative 240, and here's my synthetic division. And we're just going to pick one of these possible rational roots that we want to test out here. Okay, so I'm going to try, well, why don't we try, let's try 4. Okay, we'll try 4 here. So I'm going to try a 4. Alright. And we're just going to go ahead and do synthetic division. Alright, so we're going to bring down, I'll do this in a different color. We'll bring down the 1. So 4 times 1, well that's 4. And then we have negative 8 and a positive 4, well that's negative 4. Okay. And then we have negative 4 times 4, that's negative 16. Negative 16 and a negative 1, that's negative 17. Okay, then we have negative 17 times 4, well that's going to be negative negative 68. Okay, 128 and a negative 68, well that makes 60. And then 60 times 4, well that's going to be 240. And you can see here from my remainder, it's 0. And remember, if we have a remainder of 0, that tells us that this is in fact a root of this function. Okay, so let's keep track of this. So we know that x equals 4 is a root. So I'm going to write this up top so we don't forget. X equals 4. X equals 4. Okay, that is definitely a root. Okay, so now let's keep going. And remember, I can go ahead and write another synthetic division bar. I don't have to rewrite this. I can keep going. All right, I had a remainder of 0 here, so I can just keep going down with this. All right, and try to find another possible rational root. Again, I don't have to rewrite it. So I'm going to try, let's try negative 4. And we'll see if negative 4 works out. We'll try negative 4. And again, we're looking for a remainder of 0 here. That's how we know that it is in fact a root. So again, let's bring down the 1. And we get negative 4 times 1, so that's negative 4. And then a negative 4 and a negative 4, that makes negative 8. Negative 8 times negative 4, that's going to be 32. Okay, and then we have negative 17 and a 32, so that's 15. Okay, and then 15 times a negative 4, well that's going to be negative 60. Okay, and again, okay, I have a remainder of 0. So I know that negative 4 is also going to be a root of this function. Right, and this will come into play at the end. All right, so negative 4 is also a root. All right, now recall when we divide, we're naturally losing a degree. All right, we're losing one of those degrees when we divide. So when I divided the first time, this now became to the 3rd power. And when I divided a second time, it's now to the 2nd power. So essentially what this means is I have x squared, x, and my constant. All right, and at this point, I want to try to factor this. Because remember, this is only testing for rational roots. Okay? Only testing for rational roots. So there's a possibility that I could have an irrational root here. All right, so going for factoring, using factoring will give you the definite answer. So if possible, always try to factor. All right, so right here, I'm going to go ahead and I'm going to rewrite this. All right, so we have it down to x squared minus 8x plus 15. And we're going to try to factor that to get the remaining roots. Okay, so what I'm going to do here, I'm going to write this off to the side. So we have x squared minus 8x, okay, and then plus 15, okay? And I'm just going to erase this work. Okay. And now let's write this nice and big. So we have x squared minus 8x plus 15. Okay, and we are solving for the zeros here, so this is all equal to 0. Okay? Alright. Now that we have it down to a quadratic, right, we can try to factor this. Well, let's try to factor it using the AC method. Okay, so A times C, well, that's going to be 15, right? 15 times 1. And then what two numbers when I multiply will be 15, but add up to negative 8. Well, that's going to be x minus 5, right, and x minus 3. And again, this is all equal to 0. Okay, so we can see when we multiply these two numbers, right, that will be 15, but when we add them, it will be negative 8. And if we solve each one of these factors, right, we'll have x equals 5 and x equals 3. Okay? So we went ahead and we solved for all the zeros of this function, all right? That is what you need to do in order to factor it, okay? So the last step is actually factoring it, putting it into factored form. And the only way you can do that is if you have the zeros. So let me erase this work here. And we're gonna write out all our zeros that we found. All right, so we have x equals 4 as well. And we also have x equals -4. Okay, so the last step is very simple. All we have to do is put these into factored form. So simply moving our coefficient over. So in this case, we're going to have x minus 5. Okay. Move the coefficient over. X minus 3. Okay, x minus 4. And then x plus 4. Okay, and this is complete. So we just took the polynomial and we put it into factored form. Again, this was using the rational root theorem in synthetic division. All right, so a little involved, but a little bit of practice, you guys can also get it. All right.